Hello everyone and welcome back to our videos. Today we will talk about the aerodynamics. General Book, Chapter 2 Physics, Section D. Aerodynamics. If there isn't aerodynamics, that means there isn't lift, so the aircraft cannot fly. The aerodynamics and its meaning, that's what we will talk about it in this section. The airplanes and helicopters are able to fly only when they generate an amount of lift that equals their own weight. How they will generate the amount of lift? To understand exactly how lift is produced, you must first be familiar with the air itself. We will start with talking about the atmosphere. The Earth's atmosphere is composed of about 78% nitrogen and 21% oxygen. The remaining 1% is made up of several other gases, primarily argon or carbon dioxide. The percentage of these gases remain constant regardless of their altitude. The atmosphere also contains some water vapor, but the amount varies from almost zero to about 5% by volume. In order to have a reference of all aerodynamic computations, the International Civil Aeronautics Organization has agreed upon a standard atmosphere pressure and standard atmosphere temperature. A standard atmospheric conditions are based on a sea level temperature of 15 Celsius or 59 Fahrenheit and a barometric pressure of 29.92 inch of mercury or 1013.2 millibars. Pressure and temperature normally decreases with increase in altitude. If the altitude decreases, that means the pressure and temperature will increase. Pressure. We talked before about pressure and the type of pressure, and we said that we have three types of pressure: absolute pressure, gauge pressure, and differential pressure. Today we will talk about the units of the pressure and the atmospheric pressure. There are three systems commonly used in aviation of measuring pressure. The first one, pound per square inch. The second one, inches of mercury, and the last one, millibars. We will start with pound per square inch, PSI. The force in pounds that the air exerts on each square inch of area equal to 14.69 psi. Approximately one half of the air in the atmosphere is below 18,000 feet. Therefore, the pressure at 18,000 feet is about 7.34 psi, or half of that at sea level. That means, as we talked before, when the altitude increases, the pressure will decreases. Here at sea level, we see that the atmospheric pressure is 14.69 psi pound per square inch, but when the altitude increases to 18,000 feet, the pressure will decrease. And that illustrates what we talked about before, the relation between the altitude and the pressure. The second unit, inch of mercury. When a tube is filled with mercury and inverted in a bowl, the mercury drops in the tube until the atmospheric pressure exerted on the mercury in the bowl equals to weight of the mercury in the tube. Standard atmospheric pressure can be supported or can support a column of mercury that is 29.92 inch. Pressure that is referenced from zero pressure is called absolute pressure, and this type of the pressure. The metric unit of measure for barometric pressure is millibar. 1 millibar is approximately equivalent to 0.0295 inch, and therefore a standard sea level pressure is equivalent to 1013.2 millibars. Some altimeters have their barometric scale calibrated in millibars. Now we will talk about the temperature and the standard temperature of the atmosphere. There are two temperature scales, as we studied before, Fahrenheit scale and Celsius scale, and we know how to change from Fahrenheit to Celsius and the opposite. The Celsius scale has 100 divisions between the freezing and boiling point of pure water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The Fahrenheit scale is also based on the freezing and boiling points of water. However, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The standard temperature for all aerodynamic computations is 15 Celsius or 59 Fahrenheit. Air density. Water content of the air has a slight effect on the density of the air. It should be remembered that humid air at a given temperature and pressure is lighter than dry air at the same temperature and pressure. Humidity. As a result of evaporation, the atmosphere also contains some moisture in the form of water vapor. The moisture in the air is often referred to as humidity. So the humidity is the moisture in the form of water vapor in the air. Fog and humidity both affect the performance of an airplane. For example, since humid air is less dense than dry air, the allowable takeoff cross weight of an aircraft is generally reduced when operating in humid conditions. Since water vapor is incombustible, its presence in the atmosphere results in a loss of engine power output. The reason for this is that as a mixture of water vapor and air is drawn through a carburetor, fuel is metered into it as though it were all air. Since water vapor doesn't burn, the effective fuel to air ratio is enriched and the engine operates as though it were on an excessively rich mixture. The resulting horsepower loss. We have two types of humidity: the absolute humidity and relative humidity. The absolute humidity refers to the actual amount of water vapor in a mixture of air and water. The amount of water vapor the air can hold varies with air temperature. The higher the air temperature, the more water vapor the air can hold. The relative humidity is the ratio between the amount of moisture in the air to the amount that would be present if the air were saturated. The last thing we will talk about today, the dew point. Dew point is the temperature at which air reaches a state where it can hold no more water. When the dew point is reached, the air contains 100% of the moisture it can hold at that temperature and is said to be saturated. If the temperature drops below the dew point, condensation occurs.